So we're still continuing on getting our Twitter and Yahoo Finance. We're trying to get our Yahoo Finance data into Twitter, and we are going to attempt to publish an index every hour ad infinitum. And I just got to the point where we got down to there's two bits that I want to do that I did in the background, basically, because I did a little search straight afterwards. But as usual, like, you can't like find these things quick, like within 2 seconds when you're not looking for it. But if I just, I guess I've kind of like noted it over here. So we've got the 2-year Treasury note, and I was kind of like doing this approximation using the 13-year Treasury bill. And the original one was like, I couldn't find the right Treasury note, but I've actually found it. There's a future over here, and it was literally 2-year Treasury note futures. So, and that gives us this price as opposed to a yield that we can then convert into a price. And the futures price is generally it's going to be continuous, basically. So that's very useful for us. So the future is ZT equals F, and it kind of like works, and you can sort of like see the good history of it as well. So you can see where rates have where are they here? 6 month, 1 year. Yeah, you can see sort of like as yields have gone up, prices have gone down, and we can see some of the volatility in that price going down and up and so forth. So that's basically that's a 2-year note future price action. So that's quite good. We've got that, so we can pull it into our index over here. So we now no longer need to do the 13-year Treasury yield bill. We've actually got a future, which is helpful. So copy that and put that into here for our comment. So that's a 2-year Treasury note future, which means that we can put it over here, which means that we can remove this line of code. So now we've got our future as we want it, and also we were doing an adjustment on the future. So now we don't have to do that adjustment anymore because we are actually getting a price. So this one here, instead of being 95, it's actually going to take value of 103 if we run it. So that is really nice. And there's something else that was running actually above, which is just when I select switched off, I wanted to, because I was looking at the last bit that we left ourselves at were when we iterate through our list of tickers, kind of like what structure do we want? So when we iterate through our dictionary of tickers, so when we iterate, so this is an iterable, and we look through all of the keys, what do we want here? Do we want just a value, or do we want a list coming back with a name, price, and weight? Or do we want a dictionary coming back with also a name, price, and a weight? So kind of like what structure do we want? And then kind of like I was like, okay, I'll go back up into this function that we made. So just as well we didn't delete it. And just for a little play around, I thought I'll stick in basically data here, because what comes back from this yf.ticker is data. And I was like, well, I'll do a dot to get the methods on it and like just see what's available. Not these double underscore ones, but all of these other ones. So we can get things like ticker, sustainability, stats, splits, recommendations, quarterly intervals, cash flow. So a whole ton of stuff. Some things apply, some things don't apply. The ISIN number would be unique, which is quite useful. So it's unique for like equities. It's not unique for ETFs necessarily, but for equities it is. And yeah, a whole bunch of stuff. And what I realized, I couldn't find what I wanted, but there's a get info one here. And I was like, well, that looks a little bit useful. So I was like, get info, and so the data.info. And this data.info is this thing up here, this whole, and it looks like it's a dictionary. Now, a lot of it is useless in there for us because, well, we got the symbol, we know what that is. The 200-day average change percent, and all of this language, we don't care. Header symbol, don't care. But it did have one interesting thing, because I was scrolling across. What else does it have? 52-week high change, don't care. Keep going across. A lot of these are data fields, but I was actually looking for the name somewhere. So market is an interesting one. US 24 underscore markets. That might be a 24-hour market. So there's other really useful stuff that we can get back from this. Price hints, we don't want that one in particular. Exchange, so what exchange it's on, that could be interesting as well. Oh yeah, here, this is the one that we want, which is this short name, because that will unambiguously tell us what we're getting back. So here we've got short name gold 23, so it's our gold future. So I wonder if there's anything else there. I might actually copy this one straight out because we care for this one possibly. So copy that out because we want the short name, because that's going to be our description in terms of when we say name, because we want to do as much of this programmatically as possible so that we don't have to type things in, because anywhere we type things in, here's another one which is the exchange symbol. Possibly leave that out because I think it's a short name that we might sort of like. I'm just having a look to see if there's anything else that's of use to us there. We don't care so much for the price change things. Underlying symbol, but that's the same thing. Contract symbol. I'm just looking for the most descriptive name. Currency, expired date. Okay, so it looks like our most descriptive thing is a short name. There might be a long name as well. Regular market change, 50-day more averages, don't care for those. We're just looking for a descriptive field in there. So, okay, it looks like we'll use a short name, and we could print, so here, data.info, which returned us back a dictionary. We'll print over here, print let's get our brackets in the right place. So short name and then colon, why not just have the comma, and then here, just make sure I get it right. Well, so it'll be all of this data info, but we don't want all of the info because it's too much, and we actually want the short name. So that's the difference between this like single item thing, is we just want one thing. So hopefully we get back the short name just like that. So we could print all of the info, but let's print the short name out as well. So when we run this, we're just looking at the top piece. So we get returning two things back at the moment because we're running this function here, and then we're running the other one down below. But we just want the we want to just see what the short name looks like if we can get it, and we run it, and we do indeed. We get gold June 23. So that's quite useful. The one thing is that our short name would continuously change, so it's not just gold, but it's gold and then the year. So we might want to think about that, but that's definitely a way of getting a description into there. But in a way, maybe that's useful because we might want to know what we're indexing off. You know, maybe even if that changes because the price might jump a little bit or something, so we might need to recalibrate in some way if the futures are different. So we've got something extra that we can put into our system now, and we get that out of data. So in here, if we do name, which we might do, we would be going for tickers. If we do it like a dictionary structure, so we're going to have to be changing these into dictionary items, basically. This one here, as we said, would be name. And that means that we would be putting these all on separate lines, which is fine. This is name. in fact, we could put all of. I think everything would be suitable. So we got name, and then we'll have price and then weight for each one of these. So there's a price and there's a weight. We sort of like hit return, and that will be the next line. In fact, we just put it down there like that, since we're going to utilize a lot of space. So we've got a dictionary of dictionaries is what we're going to have for each one of these. We've got the commas already in this. We just have to replace the zeros, the space, and that. That's our next dictionary. That's our next dictionary. And so you see how this thing gets kind of like built up effectively. That's our next dictionary, and that's our next one, space that. And finally our last dictionary over here. So there we go. So a dictionary full of dictionaries. We could have had a dictionary of lists, but we're going to have a dictionary of dictionaries. And that'll be the end of it. That's the end of our dictionary. Now for each one of these, at the moment these are just strings, it's just name. But we will be changing them, and we could actually, if we wanted to, we could put in the S&P 500 because they're in order. But these names are going to change, and we can decide if we now want to overwrite the names. This is the NASDAQ. This is the 2-year Treasury. I'm not going to write that whole thing out, so two-year Treasuries, that should be more than enough. In fact, I won't even. 2-year Treasury. Two-year Treasury, that should be descriptive enough for that one. Then we've got Bitcoin next, so BTC USD, we can just call it, we call it Bitcoin, since Bitcoin normally means BTC USD. We're just calling it what we want. This one here was gold, so we'll take this one, copy that, and paste it straight out there. And finally silver. There we go. If we use lower we'll use capitals there. I don't know why, but I will be, because it's names. There we go. Now the prices, they're all just going to be floating point numbers, and we might put in a starting point because, as we said before, we need to have a reference point at least to start with. So we should, I think, be putting in these. We'll have a little think about that. I'm just sticking everything into 2 decimal places at the moment, just to guarantee that we've got floats. And the accuracy, well, it won't be amazing, but it will be, because you can see here this should be 0.12, for example, because you'd round up, you'd round to the nearest decimal place. But it's enough to be relatively good, at least for what we want. And then finally, of course, we'll put the weightings in. I'm going to keep this one as a float. I don't know, like, say for this one might never be a float. It might always be an integer, but it's got a .0 at the end of it anyway. So, which is a gold future, and our silver futures here, which is this one here. So I don't know if our gold future GC equals F, so this one here, if that is always integers, or if that was just coincidentally it finished at 1981. So I've just gone and stuck it in here. Yeah, it does have decimals, so .00, .70 there. So we can, I'll put in a second decimal place. I'm just making sure of that. So, and I guess if we go to historical data, yeah, we will see it. So it just happened to close at a 0, because I don't actually see that There's an adjusted close here, so that's an interesting one. But I imagine there must be an adjusted close and an official close. So just over here, we'll put in a 00 for the sake of it, although it came in here at 1980. 1981. It's interesting as to where the, well, that's an open. What I'm looking at, I probably need to do a plus sign because it's too small. Control plus, let's zoom in, is where that actual data point was, because I'm expecting it to effectively be the last close, which is control plus again. If we are looking at the data, it's kind of like that was the open, so it's kind of like I can sort of reconcile it: high, low, close. I'd have thought it'd be this number here, or this number, either the close of the adjusted close, or this number at the top. But it doesn't seem to be them, or any of them, but it seems to be quite close. We're not that precise yet that we care, but at some point we will care. So let me just zoom back out of that. Minus. So we've now got this dictionary of dictionaries, so it's a lot more descriptive. We've got 20%, 20%. This one's going to be 30%. This we have set ourselves. 20%, 5 and 5. One thing to check in the algo, for example, is do these all add up? So I can eyeball it. That's 20, 50, 70, 80, 90. So this makes 100%. So I've checked someone else's calculations. But if we wanted to be able to adapt the calculations, we might want to put in a check that the sum of the ticker weights all come up to 100. So now where we've gone through this, we've got for ticker in tickers dot keys, and these are the keys still. But inside of the keys, we've now, so the value that we're going to pull out, so in order to get the price, in order to get down to the price, the question is how do we get price? And it should be now tickers.ticker is going to give us this dictionary here. And to get the price, we need to do one more dictionary inside it. And this is why it's quite nice and convenient, because it's just price over here. So that will equal to the price close. So, and we could still print out our price close. That won't be any different. But our tickers now, all of the prices should have changed. So we're now going to get a dictionary coming back, and we're going to get the S&P name, we're going to get the price, and we're going to get the weighting. So we should get everything when we run this in our bit at the bottom. And we can omit running this. We don't need to run this one now because we've used our single bit, so all of that top stuff, we don't need that now. Wonder why that all came in actually, because we've got loads of prices. I didn't have a for loop in there, so that's interesting. Price equals, oh actually, so the for loop, so this only printed out one line actually, so it didn't really make that much. So we could have it in there if we wanted, but we don't need it anyway. We were running a for loop, I guess, over here, and this is our print statement, so that's what was coming out, was all of this print stuff, which we probably don't need, so we can comment that out because we're going to get back the tickers anyway. So we can now run this, Control S, and just run that piece of code, and we get back, it looks like what we want. So that's great. That is really good. Everything that we need, and we could even, I'm normally lazy at this point. I normally, and actually one of the things I might have done, like retrospectively, I've just had a good think about this. It would have been way easier to put these into lists of, a dictionary of lists, because that would have passed straight into a pandas data frame, and things like averages or sums we could have just done straight out of the pandas data frame. And that was the thing about thinking about this. So I've possibly thought about this, although this works really well, works like a treat, I'm not sure I can embed this into a pandas data frame as easily, and that might be annoying. So what I want to do is, because it's just convenient, that's all. The data frame is just an amazingly convenient tool. So import, in fact, is one of the reasons to use Python in finance, basically. Pandas, import pandas as PD, that's the idiom or the common way that we call pandas. And down here, I'm going to try to put it into a data frame, but I don't think we can put a dictionary of dictionaries into a data frame. If we can, then it's okay, I'll leave it as it is. But if we can't, then df equals pd dot data frame. It might do, because a data frame is so clever that it can normally read structures. And then we'll put off tickers, basically, tickers in there. We're just going to stick the whole lot in, and what we might just return back just now to test it out is we'll return back the data frame, and here will be a data frame, and here will be, we're just going to see if we can get the data frame. So we'll run that. PD is not defined. Okay, but that's an easy one, because we need to do the import of pandas as PD, so that's fine. And we go back, because remember we're running these in blocks, so I probably didn't have it run. So let's have another bash at that. I'm quite sure, because it said name error. In fact, it pointed to line, well, okay, name error, but PD is not defined. It says it right there. So hopefully this time round it does run, and we do get a data frame, and it has put them, it's put them this way round. And I'm thinking they would have been that way round anyway, unless we specified name, price, and weight. We could possibly, I think we can transpose the data frame. So this is a nice thing about data frames and dictionaries, is that you can sort of like manipulate them quite easily. So it's probably just like dataFrame.transpose, but just to switch the rows and the columns, just because if this price is a column header, then we can sort of like get an average price. It's just what I'm thinking about. But just out of it, I'm now just interested anyway. So, oops, didn't want to do that. Wanted to do it like that. So, pandas. Transpose a pandas data frame. So, and hit run. There was an error. Okay. Probably because I need to do, every time you need to do a restart of this. So one thing about ChatGPT, there's Google Bard, by the way, which I might have a little bash at doing that as well. So transpose pandas data frame, hit run. You know what? I'll just start it as a new thing. It's fine. Yeah, you can just use the .t. I had a feeling it might be that. It gives you the expected output, which is quite useful. So let's just try and transpose it anyway. I mean, there's just a transpose over here. So I'll go into wherever our data frame was, and then it's something like transpose a data frame. And there we go. df transpose is df.t. So now copy that. I don't know if it'll be the right format or not, but we're just going to return back df transposed. We don't need to really change this, that's fine, because that's the external variables. We're just going to print it out, so because it's still a data frame. So we've got name, price, and weight. So yeah, that's quite good. We've got options here. Just need to have a little think about what we want to get. But if, for example, we wanted to get the average price back, from here we could do df of, I guess it's going to be price. Now we're not going to do it like this. We can't do it exactly like this. But I wonder if it's dot average AV. No. I'm trying to think how we get an average of a data frame now. An average of a column of a data frame. Is it just average or df? Right, I'm too lazy to actually think about it, so it'll just tell me. Oops, I hit return there. Gives us a little example of the same data frame or something similar. Oh yeah, dot mean. There we go. Oh dear. When your brain starts going, so dot mean. We can get means, medians, the whole lot, all of our stuff. We can get. That's the thing about a data frame. Otherwise, I'd have to go and do some computations myself and rebuild the wheel. Whereas we've got this really, really powerful tool. It spits out 1,000 times more powerful things than just than just the data frame. But let's print our data. We've got our data frame. We'll print the mean, and we'll also print the data frame afterwards. So just if we do df at the end, remember that the last thing in a Jupyter notebook, but we've got our data frame here anyway now, which we could launch. We'd have to, if we did a rerun of it, we'd have to relaunch it, but that's our data frame. I could keep it on the side. I don't think, the prices aren't being modified. The Bitcoin price might change, but the rest of them I'm not sure will change. But if we run this now, just above it somewhere, I'm imagining, although I don't know where, we need to print it. So something like print we'll do an F string. Got to be careful with the F strings, because did that last time in the last video, if you remember. If you've got single quotes, especially when you're using dictionaries, if you've got single quotes, make sure you've got double quotes, because single quotes don't match with single quotes. But anyway, in here we can do the colon like this. So we could sort of like say the average price is that, basically. So, and then we could select run it, and we'll get the average prices. There we go. And we'll just round that round. We could say how many decimal places as well, to 2dp. So round it to 2 decimal places. I think that's how the rounding function works. That's the first. I'm hoping that I've done it right. I've got the brackets in the right place, because I would have expected that to move across to the next bit. So, because basically round is this number, the first number, and then the digits. But when you pass this comma part, it should have moved on to the second bit. Like, it's almost like it didn't. So, or has it done? That's number, and then n digits should be this one. It hasn't moved over to n digits. A little bit. Let's just, I'm going to run it anyway. Should have rounded it. Hopefully it does do, yeah. So, you know, if we were doing it very, very crudely, so we're kind of like part way there for an answer. We haven't really got, you know, the full answer, but we've basically been able to round, you know, this price. Now, this one is, or at least these two here, especially this one, the Bitcoin one, is 27,000 something to your other, and actually this one here, this is 12,000. That's 120,000. So Nasdaq is 120,000, Oh no, sorry, it's 12,000. I can't read my numbers. Nasdaq is 12,000 and Bitcoin is 12,000, whereas the Treasury is 103. So like, if this one moves like 1%, and this one moved 1%, the Treasury wouldn't, and the Treasury moved like 10%. That was a huge move in Treasuries. Because we haven't done a normalization yet, the Treasury thing wouldn't have a significance. So that's why, it wouldn't be satisfactory just to do a mean. Now, I've just done one just to show that we can do this convenience thing. But what we're actually going to do is the price probably divided by its original price. So this is our original set of prices. So we might have to have a Genesis tickers or original price. So we might have to have a second section of prices in, like, yeah, we will have to actually, like an original start price, and then we're going to have a like current price. So that's what we're going to need. So we're going to need, I normally call it px underscore start and px underscore end, but I guess because it's, I don't know, this is going to be our current price now. So, well, okay, these will all be our start prices, but we'll also have a current price. So we're going to have in here now here we'd have a quotations and number. So it's going to be I'm going to call it price underscore start. I don't know why. Price underscore current. Just because I've got a feeling that might be useful because it normally is. So price start, price current. Now we're leaping over the allowable amount. So really we should have a second nesting. And that wouldn't even be enough. So we're probably just going to have to break it up at this point into, I don't want to make it too big, but basically that's what it is. But it's okay in a way, because we'd rather have it to being clear, as in the Zen of Python is sort of like, let's have our clarity. So where it fits on one line, that's quite nice. But if it doesn't, let's not ruin or let's not miss the elephant in the room, which is getting this correct. So it's actually clearer this way anyway, less likely to make a mistake. And that's the thing about coding relatively well. And if we wanted to, and if this was getting too long as a list, like let's say we wanted to have an index of way more things, we just put this into effectively like a JSON file and then import it, or we put it into another file here. So we just make a new file on the side. In fact, I should actually just close this whole file system. We make a new file on the side and just literally import it at the top, just something like that. So like a data file or something. It's what we do. It's not long enough necessarily to do that, but we are growing in that direction, because each one now is going to have a price start and a price current. So after that one, each one is going to have a price start after its name. So price start, this one's going to have a price start, and this one here has got to have a price start, and this one here has got to have a current as a price start as well. And then we're going to have, and I know this nearly for a fact, but there will be confusion if we just use price. That's why I'm changing all of these to price current, so that we don't have that ambiguity. And also why I've kind of like put price at the beginning, just because experience tells me that something else, we might want to crop up another price somewhere, and then if we've used price already, it will be annoying to rechange it. So we've got a dictionary of tickers, but now we've got our start prices. Now the price that we're downloading here is going to be our current price, and that's the usefulness of it, is it's that. So here is what we've got close, and that's the thing about it, by the way. I could have put close. I'm using current at the moment, but we could use close, and I actually wonder if I should just turn it into close. At the moment, I will keep to the poor practice of current, but we've definitely, no, you know what, actually I will use close because we've got a close, so why not paste that? Yeah, we'll use close everywhere, and it's one less character. Start and close, that's quite good. Should have done open. Oh no, we won't do open because that's different. Start is our original price at you know, when we start our index effectively. So, and we want to start all our indices basically at the same at this level. So these are the values that are going to be modified, these closing prices. We could signify them by zeros afterwards. I might go back and put zeros over all of them because they're going to get overwritten. Although there is a danger that if one of them didn't get fed up into the system, that it would be then zero in our system, and that would create a nice big fat error. So I have to have a little think about that. Either way, this the closing price is going to get overwritten. That's our intention. We might even be checking for that, or we could set these all to zero and then just make sure they're never zero, because we won't ever have a zero price. So that might be a chat. We'll have a little think about that, but these ones anyway are all getting overwritten. What I might do, because it doesn't make a difference, is I will actually stick in a zero. I will do that. Zero, because we want to spot, I think. It swings and roundabouts. On the one hand, it's safer, because if the zero didn't get updated, especially on like a big number here, if the zero didn't get updated, it'd be out by a huge amount. So zero and zero. So we don't know what our closing price is, but it's going to get updated in the system. At this line, at line number 190, it's going to update all of our dictionary, and hopefully now our dictionary will come in and we'll have two prices, which is a start price and a close price, and then at the end we'll have a weighting. So it's going to look even more like what we want. Hold on, we've got a price in there somewhere. Where was that price? I've got to try and find it. Line 203 is helping me. 203. Ah, there we go. That's a nice thing as well about Python 3.11. I think it was even in 3.10, is that they introduced, the developers introduced this little arrow pointing to it, telling you exactly what was wrong, at least on the line that was wrong. But it says the key error here, price, and there's no price in the dictionary anymore because we moved it out and we changed it to price close. And they're exactly the sort of errors that you nearly always get. So, and we are doing a mean on the price close actually as well. Funnily enough, before we got to that bit, we should have got the dictionary. I think we probably did. I'm just hoping. No, we didn't, because I'd have expected to get the dictionary. Because we won't, because the dictionary came the line after it. Because Python runs itself sequentially line by line, but it actually failed the line before the dictionary. So I hit the run now, and we do get that, and this is looking good. So we got a start price, and we got a closing price, and what's quite nice is that our closing price is very close to our start price. We've just done the rounding to a decimal place. And also we notice that this one here is 1981. Oops. Okay, I clicked on it and it sort of like opened itself out. That's cool. It's fine. This one here is 1981. and this is 1996. So this gold one must be updating currently, and we're literally getting the last minutely price, which is quite good. Then I'm hoping that's what it's doing. So the Bitcoin price has definitely changed, and I could probably pull up Binance and have a look at that too, because I've got Binance running. I don't want to move it actually because my screen's, I could pull it up. I've basically got Binance running over here, so we can see that BTC USD Tether at least is 27,991. That's Tether, not dollars, but they will be. So 27,995. Tether and dollars are relatively similar. We'll have a discussion about that another time. But that looks quite good. Now we need to have I'll pull this back out because what did I do? Did I shrink that? There we go, back up. Let me just get this back out for a second, which is we need to now do a normalization of these. So we're going to need another column. This is where our expertise in pandas comes in. Sort of like, I think we're just going to have to divide the close by the start. That should be good enough. And then by this weighting, and then possibly create an index that way. So that's what I'm thinking. So we're going to do close by start. We're going to create another column basically. And I think that might be sufficient. So if we do, we'll call it, so that's the thing about this price thing. I guess we'll call it price index. It probably is. Price index might be a good name because it's each one's index from its start point. I'm going to call it price index because I haven't got that much of an imagination, and I think that's quite suitable. So when we've done all of our stuff and we've got our data frame here and we've got our transposed data frame, we now want to do, so df transposed contains two columns. I wonder if I should call it this because it's going to be quite large in terms of what it's going to be called. But our transposed data frame now, I'll go along with it. df transposed. We could set df equals. We could overwrite our data frame. Do we overwrite it? Yeah, possibly. We can do this because we don't need two sets of data frames in there. I just wonder what df actually looks like, because df it's the, I'm just reopening it. Are we ever going to have a use for going that way round? So like looking up the index name and then price and hold on. That is our data frame. That's interesting. And what is df transpose then? Oh, okay, fine. This df is df transposed. Okay. Because we've changed it outside of it anyway. Because we're doing an operation on here, what we're going to do, just memory saving or whatever, but we can just say df equals df transposed because we're just transposing the data frame. So we don't need a df transpose. That was just from the example. That was just from here. Like when you use things like chat GPT, it's really, really useful, but you can't just blindly put stuff in. It's massively helpful. It does a tremendous amount. But if you don't understand what you're asking and getting back, and you can't be bothered to read it, and you just rely totally on ChatGPT, and then it could, you're likely to fall into a pitfall. So it's a massively useful tool when used properly, but when used not properly, it's not so useful. So we've got the transpose now, and we wanted to do the column bits of it. So df of our, we're going to create a new column, which we said was going to be price underscore index, right, which is just the price normalized to 100, will equal, and then df open brackets, and then we want the other prices. So we want the end price. So every time I double click on that, it like massively opens out. So I won't do that again. So we want our close divided by df, and then we want our start. There we go. Price start there. And that should be in a string, and so should that one be in a string, because it's just a column header basically. So when we run this now, we should get, and actually I'm going to do the average price is. This is quite nice because I can change it straight from here, because we want the average price on the index. That might actually spit out the full right answer. Let's just do that. Oh, we've got the average price is 1. Because, oh, well, actually it might be, because everything's probably indexed to 1. Everything is really close to 1 decimal place. It is 1. I wonder if I can, if I round it off to like 4. I think it's still going to round off to 1, because these are so close. Yeah, like I'm eyeballing it. They're all so close to 1 that, you know, I'll stick in 4 decimal places just see for the sake of it. Yeah, there we go. So it's not exactly 1. That's cool. So it looks like we've actually solved the problem. Well, solved the problem. That's fantastic, because we don't need to print that out now. We've got it here. We've got our Yahoo data here that we've run, but we've actually got our index that's coming back. That's our data frame, and we've got the average from the data frame already. So this function here, we could call it if we wanted to, but we've commented it out, so nothing gets run there. But this function here, we can sort of like modify what we're doing. Function to get the data from Yahoo Finance, and we are going to, we will comment it a bit better. We don't have an argument coming into it yet. We could put all of these tickers, for example, as the argument, and take a dictionary coming in as the argument, and then, you know, that shortens this function. We're leaving it in the function at the moment because it's just helpful to have it there. But we are going to return a data frame, I guess. We could return a data frame, or we could actually just return the actual average price, but we're going to return the Yahoo data. So returns there's no args, but this thing here is going to return a pd.dataframe. It's going to return that. So this is like in our type in here, we're going to get back a data frame. Return a data frame containing PD containing prices. I'm just scrolling across all price, I guess all price data containing relevant price data. Just so that, you know, when we come back to this, you know, in a year's time, we sort of like know what we've got. We take no arguments, there's no arguments coming in, but we are returning something back. So it's kind of like nice to have there. Let's get that all nice and indented. So that's all coming back without having to have done any work. And we can now take all of this here, and we don't need this df anymore because we don't need the actual data frame, but we can take all of this and exit out and scroll up all the way to where we are in our command stuff. And this is the bit where it's quite nice, cos tab, it's all there. And it looks like we've literally, what we actually care about is, well, we actually care about this finally. So we're going to want to be tweeting that. But we're going to have it running in here just for ourselves. We don't need to show the data frame, but what we do want to get back. So we run this, we're not running the Yahoo get data like that. We are actually returning it back. So we see here that we're returning our data frame back, and we're using that data frame to calculate the mean. So now when we run it, we're just going to get, and I wonder if we do the whole Twitter thing as well. Well, okay, I won't do an F9 to run. Oh, I think, oh no, that's fine. I can do an F5 to run everything because the Twitter thing switched off at the moment. But we're going to get this and feed it into the tweet. So it looks like we're there. F5, amazing. Let's have a look. Hope it runs. And average price. In fact, it's not really average. Well, it is the average price. The average index, or the index price. It's the weighted average index. That's what it is. It's not even, so it's not the weighted average. So there's more to do. So that's the other thing. So we're gonna create another function here. So it's going to be the subject of another video over here. We're going to have another function to compute these. So we're going to have a function to compute the weighted average price, which is the index price. So we're close, but not fully there yet. So why did we print this data frame when we ran? Oh no, we didn't. We just got the average price here. That's cool. So the average index price. So we're kind of like close, but we haven't done a weighting. We're not far from doing a weighting because we can already create a weighted column. So we can do a weighted price now. Price index. We could do price index weighted because we know what our weightings are, which is over here. So we can even do that over, where are we? Let's scroll down a bit. So we can do a df underscore. I'm on a roll, so I did want to stop the video and then do the next bit, but since we're here, we can do a price index weight. It does get quite long. I've chosen it to be long. You could do p index idx w or something for price index weight. I'm just being fully descriptive. There's no harm in it. It's not going to like detriment because it's only like a simple calculation. And that price index weight is basically the df of the weight times the df of the price index. I'm just going to be careful about double clicking on that because it's going to reopen up on me. So we've got this one here, and then we're going to multiply it by df weight, but divide that by 100. So I will double click on it here now, and it'll probably, no, it hasn't done. I have to go to be careful about how I do it. But this is over 100 because the weight is, that's 20 means 20.2, 20%. So that's our price index weight. So going back up, so we're returning this data frame, and it's going to have this price in. It's going to have another column in here with the weighted average price. So this index here is 0.2. This is 0.2. This one's slightly less, and then we can do our weightings are some of that. So I'm doing another video on, what's the other video on? Yeah, it is. It's actually on ChatGPT. It's on the neural networks, and like these weighting things are like, okay, they're different and they're not different, but like there's a weighting process that comes into these types of things. So we're doing a similar type of weighting thing there. But what was we going to do? We were going to do that of this new thing here. So I'm going to take this price index weight because we want the average of that now, which was right up here in our main function. But we can literally do price index weight and get the mean of that. And I wonder if can I put it on the next line? No, you can't because it goes over the line. Okay. Just because this thing's becoming too long in the F string, we will put our price, we'll call it the index. This is now the weighted average index price. It's the average of the weighted average index price. No, it's not. It's the weighted. It's the index price times by its weighting. It's the average of the weighted index prices. So of weighted index price, and I'm just going to look at the index price. Well, our start index is going to be 1 always. So yeah, it'll be our index basically. And the original tweets, I've got to go and find the original tweet somewhere. Twitter was, well, I guess it's just called index, but I'm going to use index underscore price just because index might be a keyword somewhere. But the index price is basically all of this whole. I've actually rounded it. I won't round it. I'll keep that because that's what it is. That's the index price, and then we can use copy that. You can sort of like see the common sense sometimes in why you want the string to be less than, or you want to sort of like finish within this line. So when I say that line, I'm talking about like this line coming down here. It gets possibly a little bit long. Sticking that whole big thing in here wasn't actually that clean after all, so it probably didn't belong in an F string, if that makes sense. So let's just bin that, move that away, and we can now, I think I just did that anyway, but copy that, and we just want to do a rounding of the index price, and it's going to be visually cleaner to understand if we ever get back to it, that here's our computation, which is the index price is the mean of the price index weight, and I think that should be it. Let's just run that, and I've just got done. Right, why have we got, oh sorry, I did the control return, didn't mean to do that. I meant to do an F5 to run the whole thing, because control return just probably ran, I don't even know, oh yeah, control return would have run this, printed out done, and then not run the main bits, because yeah, okay, fine. So let's just hit F5 because that's the way to run all of the code. Do we get an error? No, we get it. Oh, we don't want the average. We want to get the sum, don't we? Because we want to get the weighted out. So we've got the, once we've done the weightings, so the weighted index price is actually the sum of all of these. So there we go. Dot. This one's easier. Sum. Yep, did work. Good. Okay. Because the sum of them is going to add up to 100, and we could put a check in, but obviously, you know, the check being that these add up to 100. Otherwise, if they didn't, we could just normalize them. It's not a problem. But one way or another, like if they didn't add up to 100, you'd have to do a normalization, or you check they add up to 100 and tell the user your numbers didn't add up to 100. So they're your two options. So that should actually work. F5 to run it. So, and the clue was, by the way, you know, here, wherever it was, if I open it up, there was a little clue there, but I can't find it now. I never can when I do these things. Let's rerun it. I was looking for that other result. It would come after the whole big blue thing, I guess, somewhere. Couldn't find it. No, hopeless. But the other one came in at like 0.19, basically. I wonder why I can't find it. Weighted average price, and it just comes in here, just before the next piece of code was. So that was run there. Price is all of no. I don't know. Can't find it. It was a bit annoying. Oh dear. Okay, didn't mean to do that. Didn't mean to select everything like that. I meant to actually just put mean. Because if we do run it, this is what I was looking at, was this was 1005, but the clue was if we do run it and hit F5, we'll see it all running again. You know, it was 0.19 or something, you know, 0.16. It was a tiny amount. And there we see the two comparisons now. Now we see, I don't know why I couldn't see it before control. There we go. The weighted average is way too small, and up here is the right one. Weighted average index price is that. So that's basically it. So let's change that back to sum. So we've done it. I think we've worked out the index value, and we can then go ahead to attempt to publish it. Now the thing is about that is, and this is why it's easy, is we can move the Yahoo data up above the tweet and just, I think, feed it into the tweet in some way as part of the text. So I am going to leave this till we've hit the hour period. I'm going to say it'd be fantastic if you can follow. If you're there until this point, it'd be fantastic if you can follow. I'm going to leave it on a nice ending screen, which is quite nice. And yeah, do a follow, do a like, share it all out over everywhere so that everyone can see it. And yeah, and I guess I'll continue from this point on the next video. So the next bit will be tweeting out our data once every hour or something, or we'll test it out every few minutes or something like that. So that'd be quite nice.